So what really is a virtual machine? Well, like it says here, it's a software representation of a physical computer and all of its components. A virtual machine is an application that runs on ESXi, and when I turn that application on and I look on the screen, I can actually open a console and see everything that I would normally see when I power on a real computer. I can see a power on self-test with a BIOS. I can then install an operating system into that virtual machine. That virtual machine has a series of virtual hardware components like CPU and memory and networking and disk and all of the other types of hardware that you would see in a physical computer, like sound cards and disk controllers and so on. So I power on that computer, and like any computer, if it's brand new out of the box, there may not be an operating, especially if I've built it myself, right? Think of going to an online store and buying a motherboard and a CPU and buying RAM and putting it in a case and attaching it to a network and all that kind of stuff. There might not be an operating system installed on the disk that I would also put in that computer. So I'll have to install that operating system. That operating system, like Windows or Linux or any of the other operating systems that VMware supports that run on an x86 or 64-bit platform, Intel or AMD or others, actually, we call that a guest operating system. So it's a guest of the virtual machine. So I'll attach an ISO image that includes the image for that operating system. And I will install that operating system like I would install that operating system on a physical computer. Now, here's where we do something just a little bit differently in a virtual machine than we would do in a physical machine. We install a piece of software called VMware Tools. VMware Tools is included with ESXi, and we have a button in our client that says, boom, install VMware Tools. And it runs through a little setup for that application, and there's a Windows version of it, and there's a Linux version, there's a version of VMware Tools for other operating systems as well. Okay? And VMware Tools includes some specialized device drivers to support some specialized virtual devices that we're going to attach to this virtual machine. We'll talk more about VMware Tools a little bit later, but suffice it to say, though VMware Tools doesn't have to be installed in every single virtual machine, VMware Tools should be installed in every virtual machine. Okay? So of course, once we have that up and running, we can then begin to install our applications. So we have this virtual computer with all of its virtual resources, CPU and memory and network adapters and disk controllers and all these sorts of things. And then we install the operating system, and then we install VMware Tools on top of that. Now, this seems a little bit complicated, right? Why would I want to do this as opposed to using a physical machine, for example? Well, I'm actually going to go out on a limb here a little bit, and I'm going to say that virtual machines are outright better than physical machines. I would much rather support, as an IT administrator, an application running in a virtual machine than I would running bare metal on a physical machine. Why? Why would I want to do that? Well, certainly certain applications, depending on the application, require more or less resources. Okay? Now, when I stock up or I rack up a whole rack of servers, I'm not buying junk. I'm not buying small servers, right? I'm buying really good enterprise quality, enterprise grade stuff. I'm loading it full of RAM, and it's going to be chock full of memory, and it's going to have the top of the line stuff in it. Because nobody ever got fired for buying top of the line stuff when it comes to applications that your business relies on to do its job. Now, in most of those cases, the applications that I need are not going to require all of the resources that I put in a virtual machine. All the resources that I put in the physical host. Imagine I've got a host with 512 gigs of RAM. the last thing that I need is 512 gigs of RAM for a web server, or 48 CPU cores to run a file server, right? I want to partition that physical machine, if you will, that host, into smaller chunks of resources where I'm able to right size that chunk of resources, assign it to a virtual machine, and then install an application. Okay, and right sizing my environment allows me to save a huge amount of money, allows me to save a huge amount of power in the data center, and ports on our switches, and ports on the firewall, and all of these sorts of things. So if I can take multiple virtual machines and run many, many virtual machines on the same physical piece of hardware, all of which are isolated from one another, then I'm really making much more efficient use of the physical hardware that I've bought. Now, we've already talked about the fact that these virtual machines are now portable. I can take a virtual machine running on one host, and without interrupting its operation, I can move it to another host with that feature that we call vMotion. Now, that goes a long way to maintaining that data center. If I need to take a host down in order to update its firmware, for example, I don't want to have to take downtime in an application that doesn't otherwise have any other sort of clustering mechanism in it. I'd like to simply vMotion it to another host, evacuate all of the virtual machines on the host whose firmware I would like to update the firmware, reboot it, and then migrate those virtual machines back. And we can even do that automatically when we utilize that feature we already discussed called DRS, where it'll simply just rebalance the cluster for us, which is really, really wonderful. Okay? It makes our virtual machines super easy to move around, to copy. It makes the virtual machines completely independent of the hardware that we're running on it, or that we're running it on, rather. If you think about it, if I've got a system from Dell, and it's got a Dell motherboard and all of the Dell devices, like storage controllers and network cards and all that kind of stuff, and it's over here. And I've got another system from HP or Cisco or Lenovo over here, and I'm running my operating system bare metal. I'll pull out a hard drive from the Dell and pop it into the HP. Is it going to run? Well, maybe. Most likely, I'm going to have all kinds of driver issues. It's not going to run perfectly. Virtual machines, on the other board, are all built with virtual motherboards from this company called VMware. And it doesn't matter what physical hardware it runs on, I can take that virtual machine and move it from a Dell machine to a Cisco or HP machine and back and forth without having to worry about the change in the underlying physical architecture, because the applications running in those virtual machines are only going to see the virtual architecture that we provisioned it with. So virtual machines are completely independent of that physical hardware. It also means that I can take virtual machines and install an old operating system to support an old application, even if I don't have drivers for that operating system to run on a brand new computer. How many of us are out there with old legacy applications that I can no longer support on hardware that I can buy off the shelf? Me, absolutely. I would venture to say that most of us are in that situation. Well, running those applications and those operating systems in virtual machines allows me to do that on modern hardware, which is something that we all want to do. The last thing that we want to have to do is go out there and support old hardware, having to buy used parts and things like that. Okay. Now, virtual machines themselves are isolated from other virtual machines running on the same physical hardware. They do not interact with one another unless you actually build the networking features around that. Okay. But by default, they don't interact with one another. So that if I have a virtual machine whose software becomes compromised, okay, maybe there was a hack, that doesn't mean that all of the other virtual machines and their software are also compromised. Okay? Those virtual machines are isolated from one another. If I had lots of applications running in the same physical machine, compromising one of those applications would likely lead to the compromise of lots of others running within that same operating system. Virtual machines are also insulated from hardware changes. If I want to add RAM or change CPU in a physical server, that doesn't affect the virtual machine that is running on that server, because the virtual machine only sees the virtual hardware that you've assigned to that virtual machine. It doesn't see the physical hardware necessarily. So those are all great advantages of virtual machines. Physical machines, on the other hand, are difficult to move. If I wanted to actually move a physical machine from one data center to another data center, I have to take downtime. And if I can't cluster the application running in that system, I have to take downtime in that application, and we don't want to have to do that. Of course, those physical machines have a physical hardware complement that the operating system installed on it must rely upon. So those applications running in that operating system are really bound to that physical machine and cannot run on another physical machine unless it's identical. And I pull the hard drive out and pop it in another one, and of course, boom, it works, maybe, right? We also have to have physical contact in order to upgrade the hardware to support those applications. In a virtual machine, we just click a couple of buttons, change the number of virtual CPUs from 4 to 8, and all of a sudden the applications now have 8 CPUs to work with. Well, isn't that great? I didn't have to touch anything in the physical data center. I didn't have to drive there, let alone be there at 2 or 3 in the morning when supposedly the resource usage or the utilization by my users is lower. Okay, so lots of benefits then to running virtual machines over physical machines. Now, server virtualization is not the only type of virtualization that VMware supports. Okay? We also have network virtualization, where we can extend our networks across multiple hosts and across multiple data centers and include things like software-defined switches and routers and firewalls and load balancers and all of those sorts of things within and managed entirely upon our ESXi infrastructure. So network virtualization with a product called NSX is another type of virtualization that we can choose to implement once we have our basic server virtualization taken care of. We also have storage virtualization in the form of something that we call hyperconverged infrastructure, where we'll take, instead of a monolithic storage array, external storage array, we'll populate our ESXi hosts with things like solid-state devices and utilize all of the solid-state devices within the hosts in our cluster to create one large aggregated chunk of storage that we call a vSAN data store. This really allows us as vSphere administrators to take control of the storage requirements for the applications running in our virtual machines. So vSAN is a storage virtualization product that VMware includes, and we're actually going to be looking a little bit at vSAN as we go through the course here in our storage environment. Other types of virtualization include desktop virtualization, where instead of running server-based operating systems like Windows Server, okay, we're actually going to do desktop type virtualization like with Windows 10 or even with Linux, where we will provide, instead of physical machines in front of users like laptops or desktops full of CPU and memory, we'll just give our users essentially a dumb client or a thin client that allows them to connect very nicely to a virtual machine running the applications that they need. And in that case, our users get the benefit of virtualization without having to have these big physical machines in front of them, without having to have IT crawling under the desk when something goes wrong and having to switch out hardware and having to maintain hardware that is sitting on physical desks and things like that. So desktop virtualization is a way when we're running large organizations with lots of desktop users, providing them virtual machines is much, much easier on us as administrators than providing them with physical machines. So all of these sorts of technologies then fit within the larger software-defined data center. Okay. Now, if you have a look at this here, we have at the bottom this physical layer. okay? Where our physical hardware lies. Our computers, our physical hosts, our storage, and our networking. And on top of that, of course, we build our virtual infrastructure, like our ESXi hypervisors in vSphere, like vSAN to aggregate our storage within those physical hosts, and NSX to establish our software-defined networking across our data centers. Now, all of that can be managed through a cloud management layer that allows us to orchestrate the deployment of these software-defined data centers. Orchestrate the deployment of lots of virtual machines together, lots of virtual networks, okay, that allow us to provide a service catalog of applications that require multiple virtual machines to our users to select them, to boom, provide all of the virtual machines, the applications in those virtual machines, and all of the configuration around storage and networking that goes with it, all in an orchestrated fashion. So all of those components can then be managed by vRealize operations. And vRealize operations can allow us then to get a big picture in terms of the performance of those systems. vRealize automation does the orchestration piece. And vRealize Orchestrator can dive even deeper into allowing us to create our own orchestrations around workflows involved in the software-defined data center. Now, of course, all of this stuff requires some business continuity features. So vSphere replication is another component that allows us to replicate the virtual machine's files from one storage array in one data center to another storage array in another data center. Okay? We also have Site Recovery Manager that can take those then virtual machine files that are existing in two different locations and automate or orchestrate the failover of one data center and all the virtual machines running in one data center to another physical data center. Of course, all of this also requires security. So we have components like app defense running inside of our virtual machines, microsegmentation, and carbon black that can give us that full and complete security picture for the entire software-defined data center. So VMware now becomes this one-stop shop for running the entire data center for us. Well, that's all well and good, and we've covered a lot of different things here. But just so you understand where we sit, we are right here in the middle of all of this with our virtual infrastructure layer. Okay. Now, how does all of this then fit into cloud computing? Okay, well, it does in that cloud computing is a term that is more and more understood, I suppose, but really cloud computing is just your software running in somebody else's data center. That's really all it is. Now, in some cases, we'll have our own private data center. That's the ones that we traditionally understand. But we may need to expand or move some of our stuff into a public cloud. Now, doing this and being flexible about this, moving workloads into the public cloud, out of the public cloud, from the private data center over to the public cloud, without any sort of interruption in service has always been a big challenge, and until recently was downright near impossible. Well, VMware has come along with a strategy called the hybrid cloud. And this hybrid cloud allows us to interoperate and to move our workloads between the private and public clouds that you may choose to join. So many public cloud providers like Amazon with AWS and Microsoft with Azure, okay? And IBM with their cloud infrastructure, and on and on and on. All of these hyperscaler infrastructure companies are now working with VMware to allow you to run your workloads really anywhere that you would like to go. Okay? Implementing, of course, your server virtualization and storage virtualization and network virtualization okay? And bringing all of those together with kind of a one-click or one-stop shop product called VMware Cloud Foundation can really be an advantage to a lot of organizations, allowing you to manage your own data centers regardless of whose hardware they happen to be running on. Now, in many cases, I need to know at all times about that physical infrastructure. How is the infrastructure doing, right? Is my hardware healthy? Am I going to run into any issues? Am I running a piece of hardware that needs a firmware update in order to operate more neatly or nicely with VMware's set of products? Well, VMware has a relatively new set of features called Skyline. Okay? And Skyline can inform you proactively when there might be some hardware issues going on in the environment. Okay? This allows us to avoid potential issues, identifying things like hardware incompatibilities, identifying things to us like hardware failures or component failures within the hardware, allowing us to resolve these issues really before they become major problems. And certainly allowing us to shorten the time to resolution because Skyline gives us links to KB articles, allows us to create help requests and support requests from VMware, gives us personalized recommendations about what we need to do to best support our physical environment. You need to upgrade this storage controller from firmware version X to firmware version Y in order to support VMware 7, for example. Okay? And Skyline is included with vSphere at no additional cost and gives you extra features based on the level of support that your organization has purchased from VMware. There are a couple of different components available with Skyline. And the first one is called Skyline Health. Skyline Health is built into vSphere and vCenter and your vSphere client. Okay? It was introduced with vSphere 6.7 Update 1. And this gives you all kinds of information about your physical hardware, goes out and double checks against the hardware compatibility lists and things like that. Now, if you have production or premier support, you can also get a component called Skyline Advisor. This actually runs a data collector within your environment. It's built in as a virtual machine. And it supports more than just vSphere and vSAN, but it extends it to NSX and vRealize Operations Manager and Horizon. Okay? And this actually even supports, because it's external to vCenter, runs in a separate collector, older versions of ESXi and vCenter itself. Okay? So that's also another feature that you can add to your environment if you have production or premier level support. So that does it for lesson 1. We've looked into some basic concepts of virtualization and those terms that we all need to understand, I think, before we dive in to the rest of the infrastructure and we start taking a deeper dive. Okay? We've looked at how vSphere fits into the overall larger software-defined data center, and we looked at even some of those systems that allow us to proactively manage the vSphere environment, like Skyline. When we come back, we're going to look at really how ESXi virtualizes resources like CPU, memory, network, and disk. We'll see you real soon.